Okay, one thing before we start this unit, Unit 8 on trigonometry, make sure that your mode is in degree mode. Again, if you're using the graphing calculator, you can press the mode button, and then just make sure that instead of in radians, that it's in degrees. If you don't have it, if you have it in radian mode, you're going to get answers that are completely different. Okay, so just make sure that we do that before we begin. All right, so today we're going to be recalling a couple things from geometry. Everything we do today should be review from geometry. And we're just going to think about the trigonometric functions that you guys learned in geometry and that we reviewed in the homework yesterday. When we have the sign of an angle theta, this theta just represents an angle measurement. And the sign, we think about the opposite side over the hypotenuse. When we have cosine, we think about the adjacent over the hypotenuse. And when we think about the tangent, we think about the opposite over the adjacent. Let's pretend that we're thinking about angle A in this particular triangle. The side opposite of angle A is the one that is across from it. There are two sides that are adjacent to it, but there's one that's more important than the other. The one that's across from the right angle is the hypotenuse. And the leg of the triangle that is next to the angle is the adjacent. So it's true that there are two sides that are adjacent to the angle, but we're going to, the idea of it being a hypotenuse across from the right angle kind of trumps that other piece, okay? Another thing that we need to keep in mind in today's lesson is the Pythagorean theorem. This is something that we can use for right triangles, and that's that a squared plus b squared equals c squared, where a and b represent the legs and c represents the hypotenuse. Okay. So yesterday you guys practiced using your knowledge of trig to find side lengths. Let's also review this morning how we can use your knowledge of right triangle trig and inverses to find angle values in a right triangle. This is asking me to find the measure of this angle theta. And again, this theta is just an angle measurement. So if we look at what we know, like using these words, opposite, adjacent, and hypotenuse to describe this, notice 9 is across from the right angle, so that makes that the hypotenuse. 4 is next to the angle, that makes that the adjacent. What's the trig function that we use when we know adjacent and hypotenuse? Cosine. So we're going to say the cosine of theta, theta just represents our angle, equals the adjacent, which is 4, over the hypotenuse, which is 9. Now we're not taking the cosine of 4/9. We want the cosine of theta to give us 4/9. So really what's happening is that, you know, when we solve for theta, like when we solve for something, we want to do inverse operations, right? The inverse of addition is subtraction. The inverse of multiplication is division. The inverse of cosine is inverse cosine. And I won't make you write this every time, but essentially what you're going to do is take the inverse cosine of both sides. What do you think happens to inverse cosine and cosine? They cancel, and we just have theta. And then over here, we have the inverse cosine of 4/9. And that's going to be how we find our angle theta. Now, in your calculators, oftentimes you have to hit the second key and then the trig function. So if I wanted to get to inverse cosine, I'm going to hit second cosine, and then notice this inverse cosine shows up. And then we're going to take the inverse cosine of 4/9, and that gives us the angle measurement that we want. We should be getting, it says to round to the nearest tenth, I think. So that should be 63.6. Because I'm rounding, I'm going to use the approximately equal to symbol, and then I'll have the 63.6. And something very important that we need to remember is because we are in degree mode, we're going to make sure that we have the degree as a symbol. Within this unit, we're going to learn a new way to measure angles called radians. So the degree symbol is important so that we can distinguish between those two methods. Okay. Let's review the same thing in letter B. I look at this angle theta, and I think about what relationship 8 and 10 have to that angle, opposite, adjacent, hypotenuse. What would you call 8? The adjacent. What about 10? The opposite. What trig function deals with adjacent and opposite? Tangent. Now remember that the tangent is opposite over adjacent. So I'm going to put 10 over 8. And then essentially what I want to do is think about taking the inverse tangent of both sides. It will cancel on the left, and on the right we'll be left with the inverse tangent of 10/8. And then we can just put that in our calculator. The inverse tangent of 10/8. Oops, it's glary. And are we getting about 51.3 degrees? Okay. Let's look at one more in letter C. They give us an angle to focus on. And what would we call these side lengths in relation to the angle theta? What, opposite? And this is across from the right angle, so it's the hypotenuse. What trig function deals with opposite and hypotenuse? Sine. So we're going to take the sine of theta, and remember sine is opposite over hypotenuse. Now, my goal is to get to theta, so I have to do the inverse sine on both sides. So I can take the inverse sine of 5/12, and we should get about 24.6 degrees. Okay. Take a second and do the you try question if you haven't done that one yet, and let's see if we can get the correct answer there. Okay, so this is what the setup should look like for the you try question. The tangent of theta equals 17 over 6. So then we can take the inverse tangent to get that theta is about approximately equal. Make sure you check for that, and that you have rounded correctly, and that you have the degree symbol. Okay, we all right with that? Starting to come back a little bit. Okay. So when we solve a right triangle, solving a right triangle means that you're going to be finding all, and then I'll say missing. You're going to be finding all missing side lengths and angle measures. So you're going to have a right angle in there that makes it a right triangle. And then they're going to give you two other pieces of information, either a side and an angle or two sides. And then we're going to find the missing pieces. So they give you 3 pieces, we're going to find 3 pieces. When we find sides, we use trigonometric ratios, like we did in the homework. When finding angles, that's when we have to use the inverse of the trig ratios. And that's what we just reviewed together, is finding the inverse of those trigonometric ratios. And just remember, make sure that your calculator is in degree mode. The scientific calculators will default to degree mode usually, but the graphing ones default to radian mode. So if you ever borrow one, you have to make sure to go in there and change that, okay? So let's practice solving these different triangles. Okay, so we have a right triangle. We know that, so there are a couple ways, by the way, that you can name these, and I may have done this in the homework answer key. Across from angle A is called side A, but it also could be called segment B, or like the length of BC. You guys remember that from geometry? That you can, that A, this side that's labeled little a is the same as BC, What is side B the same as? AC. And side C is the same as AB, okay? We'll just in our notes use the ABC. Either one is fine, like they're both fine. If you have angles labeled like that, either one is acceptable, okay? But we'll just use the little letters to kind of help us out. What I've done here for you guys in the notes is I've drawn triangles for each one of these. I think that that's very helpful for you to do for each problem. So in the homework, if you don't have one drawn for each one, maybe do a little sketch. I just put these in to help us expedite things a little bit. So let's look at example 2A. This says that side C is 20. That means that across from angle C, that side is going to be 20. It also tells us that the measure of angle A is 54 degrees. Okay, so we can label the information that we have. We now want to find angle B, side B, and side A. Okay, let's do the hard part first, and then I'll save the easy part for the end for this one. So if we are trying to find, let's say that I wanted to find side A, which is across from here. Okay. What trig ratio could we set up to help us? If we look at 54 degrees, A is opposite, 20 is hypotenuse. What trig ratio uses opposite and hypotenuse? Sine. So we could say the sine of 54 degrees equals our opposite, which is A, over our hypotenuse, which is 20. And yesterday in the homework, you reviewed how to solve that. What would we need to do to isolate A? Multiply by 20. So I have 20 times the sine of 54 degrees equals A. Now, am I using inverse in this problem? No. I'm just punching in 20 times the sine of 54. And let's round to the nearest tenth like we were doing in the other pieces. And are you guys getting about 16.2? Okay. Let's do the same thing with side B. So I'll label this side B. And if I'm looking at 54 degrees, and let's try not to use the 16.2 unless we absolutely have to. All right, let's use the exact answers that we know. We know that the angle is 54, B is adjacent, and 20 is the hypotenuse. So what trig function could we use here? Cosine. We could say the cosine of 54 degrees equals our adjacent, which is B, over our hypotenuse, which is 20. Now what would we need to do to isolate B? Multiply by the 20 to get rid of the denominator of 20. And then we can just put in 20 times the cosine of 54. And rounding to the nearest tenth, that gives me about 11.8. Okay. Now there's one thing that we haven't found yet. What is the one thing we haven't found? Angle B. Do you guys remember what the sum of all the angles of a triangle is? 180, right? So what we could do is take 180 minus the 90 degrees of angle C minus the 54 degrees for angle A, and that gives me the measure of angle B. And that is 36 degrees, okay? Remember from geometry that when you're giving angle measurements, I know that last year maybe they weren't as picky, but like we usually have the measure of angle B, and this wasn't an estimate, right? Because that was exactly where we had it equals, okay? And that's solving a right triangle, okay? Let's try another one that's like that in letter B. Let's label what we have. We have that the measure of angle A is 32 degrees. And we have that side B, which is across from angle B, is 10. Okay. What would you guys like to find first? Hypotenuse, okay. So our hypotenuse is going to be labeled as C, okay? So 10 is adjacent, C is the hypotenuse. What would we need to use for that? What's adjacent and hypotenuse? Cosine. So I'm going to say the cosine of 32 degrees equals my adjacent, which is 10, over the hypotenuse, which is C. Now, these steps for solving are a little bit different. Didn't we clear the fraction before? That's what we want to do here. We need to think about multiplying by C. So I have C times the cosine of 32 degrees equals 10. And then ultimately, what are we dividing by? Well, we have the 10. To isolate the C, we're going to divide by the cosine of 32 degrees. Now, I would suggest writing these steps out until you get used to it again. Eventually, if there are probably some of you guys that can jump right from this step to the isolation of C. But until then, just make sure that you show those steps so that you're getting the groove there. And in the calculator, we'll put 10 divided by cosine of 32. So that tells me that C is about 11.8. Let's find the other side. Side A is across from angle A, and we don't know that. That is opposite. And instead of using the hypotenuse C, because that's an estimate, I'm going to use what I know for sure, that exact value of 10. So if I have the opposite and adjacent, that means that I can use the tangent. So my tangent of 32 degrees is my opposite A over the adjacent 10. Again, to clear the fraction, I multiply by the denominator, which is 10. And multiplying by the denominator isolates the A. So I just punch in 10 times the tangent of 32. So my A is about 6.2. All right. What's the one thing we have left to find? Angle B. And again, we can take 180 minus 90 minus 32. I don't need to see work for that, okay? You can show it if you want. And what happened when we subtracted all those? Oops, it should be equals, not approximately, my bad. Yep, 58 degrees, I think I heard, good. Okay. Because these are right triangles, you could also just take 90 minus 32, that's fine as well, okay? All right. So letter C, A is 7 and B is 12. So I'll label that side A across from A is 7. Side B across from angle B is 12. Now, let's think about what we could do to find another side. What could we do if we wanted to find this side up here? Okay, so the issue with sine of 90 is going to give us 1 if we use that. But there's something else that we reviewed, the idea, some of you guys were saying it's the Pythagorean theorem, right? So if you know two sides of the triangle, we can find the other side. And the reason that I'm using the Pythagorean theorem in this case is because 7 and 12 aren't rounded. In the other questions that we did in example 2A and 2B, our sides were rounded, so it would kind of be silly to use the Pythagorean theorem there, because we don't want to like go off of anything that we rounded. But we can take 7 squared plus 12 squared, and that gives me 193. And we are rounding to the nearest tenth, so we can just take the square root of 193, and that gives us about 13.9. Okay. Now, even though we've found that side, because it's rounded, I wouldn't recommend using that in the trig ratios. Okay. So let's pick an angle to deal with. What angle do you want to deal with first? We know C. You guys want to do A or B? A? Okay, sounds good. So let's talk about angle A. Okay. Let's not use C because that's an estimate. But what do we know about 7 and 12? We know that this is, so we can say the tangent of A equals the opposite, which is 7, over the adjacent, which is 12. So since 7 and 12 were opposite and adjacent, we can use tangent. Now, should we put the tangent of 7 over 12? Not in this case. We need to isolate A, which means to get rid of tangent, we have to use the inverse tangent. So the measure of angle A is going to be the inverse tangent of 7/12. So I can take the inverse tangent of 7/12, and if I round to the nearest tenth, that tells me that the measure of angle A is about 30.3 degrees. Okay. Now, we could set up another trig ratio, but if you know two of the sides of the triangle, can't we find the other side? What could we do to, or the other angle, what could we do to find the other angle? Just subtract 180 minus the 90 degrees, that is angle C, minus the 30.3 degrees, that is angle A. We see that the measure of angle B is about 59.7 degrees. Okay. Is this starting to come back a little bit? Nah, it's good. It is proper. So for my friends that teach geometry, I want to reinforce what they should have done last year, okay? All right, so letter D, we have that side B is 10. So across from angle B is side B, which is 10, and side C is 21. So once again, we could start by finding side A, because we know two of the three sides in the right triangle, but we are not going to say 21 squared plus 10 squared equals A squared. The hypotenuse has to be that C. Which one is the hypotenuse? The 21. So I have to take A squared plus 10 squared equals 21 squared. So then we could take 21 squared and subtract 10 squared, or you could find what each of these is and then write out more work, that's fine. I got that A squared is 341, you guys agree? Okay. And then we'll just take the square root of that, and A is about 18.5. Okay. Again, these aren't drawn to scale, as you can see. So now let's find the measure of an angle. Do you guys want to start with angle A again? Okay. Now, instead of using side A, though, let's use the fact that we have 10, which is adjacent and exact, and 21, which is the hypotenuse. What trig function should we use for adjacent and hypotenuse? Cosine. So we're going to say the cosine of A equals our adjacent, which is 10, over our hypotenuse of 21. Okay. Now, what do we need to do to find angle A? Use the inverse. Very nice. So let's take the inverse cosine of 10 21st. Oops. And that gives me that the measure of angle A is about 61.6 degrees. Remember, don't chop off the decimal. Look to the right and see if we have rounding to do. And then what's a quick way we could find the measure of angle B? Just subtract 180 minus 90 minus 61.6. That gives me that the measure of angle B is about 28.4 degrees. Okay. All right. So that's a little bit about solving right triangles. Feeling pretty good? All right. Now I don't want you to freak out, and I'll put the U-tries up on the Canvas website. I don't want you to freak out if there are words like there are in example 3, okay? It doesn't make things any different. So example 3 says you're hiking towards a main road, but you reach a point where the road is flooded. To avoid the flooded area, you turn onto a diagonal road that meets your original road at a 48-degree angle, and you follow that road for 3.6 miles until you hit the main road. How far were you from the main road when you turned onto the diagonal road? Okay, well, my friends, there's just a triangle that's here. This is a right angle. We turned here, so this angle is 48 degrees. It said that we traveled 3.6 miles on that diagonal road, which is like our hypotenuse. And it wants to know how far from the main road were we when we turned. Well, this is the main road. Aren't we looking for this distance? We're just looking for how far were we from the main road when we turned. And instead of solving the whole triangle, we're just finding one of the sides of the triangle. So let's take a look at that. If I were to set this one up, if I look at the 48, I think about the 3.6, which is the hypotenuse, the x, which is the adjacent. What trig function would I use? Cosine. So I'm just going to say that the cosine of 48 degrees equals, cosine is adjacent, which is x, over the hypotenuse, which is 3.6. What would we then do to solve this problem? Do we have to use inverse? No. But to isolate x, I need to multiply by 3.6. So we can just put 3.6 times the cosine of 48 in there. And we're rounding to the nearest tenth, so about 2.4. And because this problem did give us units, let's say that that's going to be 2.4 miles. Okay. Same type of thing in example 4. A monster truck drives off a ramp in order to jump onto a row of cars. So here's a little ramp, and here are my cars. Okay, I can't draw. Okay. All right. It says the ramp has a height of 10 feet. If the height is 10 feet, doesn't that mean that the vertical piece from the bottom to the top is going to be 10 feet? Okay. Now it says the truck drives 26 feet on the ramp. Which part is on the ramp? The hypotenuse. Very nice. So that's 26 feet. And it wants to know the angle of the ramp. So there's our little angle of the ramp right here. How far is it being elevated from the ground? So let's look at that. In relation to this angle theta, we have 26, which is the hypotenuse, and 10, which is the opposite. So what trig function could we use there? So for opposite, we're going to use sine. Sine of theta equals my opposite over my hypotenuse. Now our goal is to get theta by itself, so what do I have to use? Inverse sine. So I can take the inverse sine of 10/26, and that gives me about 22.6. Don't forget your degree symbol. That would be the angle of the ramp. All right. Okay. So those weren't bad. I know they had words next to them, but those shouldn't be too bad. The last thing I want to review from you from geometry is this idea of the angle of elevation and angle of depression. If you look up at an object, the angle your line of sight makes with a horizontal line is called the angle of elevation. Okay? You're starting at a horizontal line and you're looking up. That's your angle of elevation. Okay? If you look down at an object, so again, you're starting at the horizontal line and you're looking downward, the angle your line of sight makes with the horizontal line is called the angle of depression. Always remember that angles of elevation and depression are measured from the horizontal line, okay? They're always from the horizontal line, never from that vertical line. So example 5A says from a, oh, and one thing, what do you notice about the angle of elevation and angle of depression? Do you remember that they're the same angle really, right? Those are alternate interior angles, which means that they're the same. So if they give you an angle of depression, it's really like an angle of elevation and vice versa. And that can help us in our pictures sometimes. So let's look at 5A. It says from a point on the ground, 28 feet from the base of a flagpole. So here's a flagpole. And we have a point on the ground 28 feet from the base. It says the angle of elevation to the top of the flagpole, so I'll go up to the flagpole, is 63 degrees. We're going to assume they put the flagpole in nicely and it's a right angle. Okay. It says to the nearest foot, estimate the height of the flagpole. So I'm going to be looking for the height here of the flagpole. Well, now that we have the picture, we can make our ratio. In relation to 63, 28 is adjacent and h is the opposite. What trig function could we use here? Tangent. We could say that the tangent of 63 degrees equals, now which one goes on top? Opposite, which is? So opposite of 63 is the h, okay? Our goal is to isolate h, so we need to multiply by 28. Okay. And do we need to use the inverse in this problem? No. So we can just punch in 28 times the tangent of 63. We get that h is about 54.95. It does say to the nearest foot. So to the nearest foot, that would be about 55 feet. Okay, next one. 5B, a parasailer is attached to a boat with a rope 300 feet long. Okay, so here's our boat in the water. Okay, and is the parasailer going to be next to the boat? A parasailer is going to end up being above the boat, right? Okay, so here's our boat. Here's our parasailer. Okay, that looks very scary. Okay, and the rope is 300 feet long. What would we label if we're thinking about these triangles as 300 feet? If the rope is 300 feet long? Yes, the hypotenuse is going to be the 300 feet. Okay. Now it says that the angle of depression from the parasailer to the boat is 38 degrees. That does not mean that this angle in here is 38 degrees. That means if you drew a horizontal line, that angle is 38 degrees. It's very important that we always measure our angle of elevation and depression from our horizontal line. Now that being said, if this angle is 38 degrees, then isn't an angle of our triangle 38 degrees? And isn't it this one down here? So we can use the fact that that was the angle of depression to label the angle of elevation, which is really inside the triangle. And then it says it wants to estimate the parasailer's height above the boat. So the height is going to be, again, this part here. And in relation to 38, h is my opposite, 300 is my hypotenuse. What could we use there? Sine. So we can say the sine of 38 degrees equals the opposite, which is h, over the hypotenuse, which is 300. Now the goal is to isolate h, so what do we need to do to find h? Multiply by that 300, do that inverse operation, and we're ready to type that into the calculator. 300 times the sine of 38 means that h is going to be about 184.7, but again it says to the nearest foot, so that would be about 185 feet above the boat. Okay. Let's try one more review problem. Example 5C says if a building that is 52 feet tall, okay, casts a 23-foot shadow, where does the shadow end up? On the ground. What is the angle of elevation to the sun? And essentially the angle of elevation we know is just going to be measured from this horizontal. Just put on there. So if we were to set up a trig ratio based on what we have, what do you think that we should use in this problem? We have 23, which is the adjacent, 52, which is the opposite. So what does adjacent and opposite use? Tangent. Now remember though, tangent is opposite, which is 52, over the adjacent, which is 23. Okay. We're trying to get theta by itself, which means we have to use the inverse. And then we can just punch that in, the inverse tangent of 52 over 23. This says to the nearest tenth. So because we're rounding, use approximate. Nearest tenth is going to be 0.1. And what else should I put before I happy cloud my answer? The degree symbol. Okay, very nice. Why don't you guys try the last one? I pass out the homework for you. Okay, how'd the U try go? So about 34 feet. Again, even if you're not going to draw like a tree, at least draw the triangle for your pictures, okay? On the homework assignment, I think in the answer key, I didn't call this side M, I called it KL, but either one is okay, all right? So just double check those different pieces. The module, I think I have to put on the top, but you guys should be able to